In this section, we're going to take a look at the command line configuration for two of our security features, TCPintercept and uRPF. So here we have the basic topology we have. On each of our devices, we have a loopback address of the format of 150.1.x.x, where x is the device number. So for router 5, 150.1.5.5, router 6, 150.1.6.6, router 4, 150.1.4.4. Two VLANs in use, one VLAN connecting router 6 to router 4, and one VLAN connecting router 4 to router 5. So we have router 4 in the middle. We will be enabling our features TCPintercept and uRPF on router 4 and looking at the behavior as we pass traffic from router 6 to router 5. So starting on router 4, for the TCPintercept, we're going to start by configuring an access list. Now we're just going to go ahead and look at traffic passing through router 4 to router 5's loopback. So for our access list, just going to have a basic access list, and we're going to match TCP connections to router 5's loopback at the address 150.1.5.5. Now with the default mode of intercept mode on TCPintercept, we're going to go ahead and also enable this with IP TCPintercept and referencing that list. Now taking a look currently for show TCPintercept connections and statistics. And not showing any established connections and statistics. Currently showing 0 connections. So now we're going to go ahead and trigger some traffic from router 6. We're going to go ahead and establish a session through to router 5. And just logging in there. Now jumping back to router 4, taking a look at that output again, showing we do show one established connection, and taking a look at that connection information, showing that information, client and server information there for that established connection. And also showing our mode here as intercept mode at the end. Now on router 6, we're going to go ahead and disconnect this session and verify that that does show as a closed connection. It's no longer showing up as a established session. Next, we're going to go ahead and take a look at some debug information. So we're going to do a debug IP TCPintercept. And we're going to leave that debug running on router 4, go back to router 6, establish another connection through, and come back to router 4 and take a look at that debug output. Alright, so we have our session established there. Coming back through, looking at this debug output with the mode of intercept for our TCPintercept. So starting off, we have the connection coming in from router 6 to router 5's loopback address. Now with TCPintercept in intercept mode, the device in the middle, router 4 in this case, physically proxying that TCP handshake. So we have this information being sent back, this AXIN being returned, that's being sent back from router 4. So with that connection being sent back, then we have a notification here. First half of connection is established. So received that ACK back in. So then from router 4, proxying the other half of that, working on the connection, sending that SYN traffic onto the other host, and getting that second half of connection established. And then taking those two connections and grouping them together between the end host router 6 and router 5. Now if we take our connection here on router 6, we're going to go ahead and disconnect this one. And we're going to come back to router 4, and we're just going to change this to watch mode. And with the configuration in watch mode, we're going to go ahead and establish that connection again from router 6. And take a look at the differences in our debug. So in the debug differences here, just watching the connections, so just seeing the connection go through, not proxying that handshake. And slightly different output here, not showing as a active intercepted connection. And showing here in the connection request, but not in the list of current established connections. So slightly different behavior from statistics and what's gathered depending on what mode you're in. Also slightly different debug mode, whether you are in watch mode or whether you're in intercept mode. We're going to jump back to router 6 here and go ahead and just clear out these screens. Next, we're going to take a look at uRPF. Okay, so taking a look at uRPF, uRPF doing path checks, looking at where the traffic came from, looking locally on the device for a valid path to get back to that source. Now, some slight change in our topology here on router 5. We have a new loopback that we've added, loopback 99. Now this loopback address 99, 99, 99, 99 is not added into the routing protocol. So if we look for that route on router 4, we're going to see that that's not in the table. So on router 4's interface, we are going to configure uRPF on the interface facing router 5, and we're going to have router 5 generate some traffic from that loopback address. Now to start, we're going to test and show verify without the uRPF on. And on router 5, we're going to go ahead and just ping router 6. And on router 6, make sure we have our debug turned on. We have debug IP-ICMP turned on router 6. And we generate this traffic on router 5. That traffic is going to be passed through router 4 and then routed on to router 6's loopback. Now, router 4 doesn't have a route for the return path, neither does router 6. But in this case, the traffic should make it through to router 6. And pulling back to the debug, we do see router 6 trying to send the echo reply, however, would have failure because router 6 does not have a route for that network. So that traffic with that other address that was not reachable made it past router 4 and got onto router 6. Router 6 said, hey, I don't know where to send this traffic. So next we're going to go ahead and turn on the path check on router 4's interface. And just enabling it on the interface itself with a single command, IP verify unicast source reachable via, and we have two different options here. Any will give us what's called loose mode, so any route in the routing table. RX being that it has to be on the interface where that was received. That'd be strict mode. And other miscellaneous options we have here at the end, we have options of having a separate access list for overrides. We have options of allowing a default route to match, allowing self-ping, allowing the device to be able to ping itself, or just without those other options, just the basic strict mode. Now, we did not add in the allow self-ping, so if we try just on the local device pinging our own address, and just ping our own address on the interface, in this case, because of the uRPF, that ping would fail. Now if we go ahead and just add that back on, that ping should be successful. Now verifying our information here, we did have those packets that dropped on trying to ping ourselves. Taking a look at our interface information, show IP interface FA01, and taking a look at our interface counters, we do show that for the uRPF feature, IP verify, reachable via received, we did have those 5 verification drops. So next we're going to go back to router 5 and generate some more traffic. Now router 4 doesn't have a route to this source. Before, without uRPF turned on, router 4 just looking at the destination and routing the traffic on through. Now with uRPF enabled on the interface, router 4 should drop that traffic and it will not make it through to router 6. And we're just going to add in a repeat value here, and we'll do a repeat of 15. And switching back to router 6, we don't see any debug information showing up there, so we're not getting traffic through. And take a look back at our statistics here. We now show 16 drops. And now 20 drops. So showing that it is the uRPF functionality that is causing that traffic from router 5 to be dropped. So here we took a quick look at the uRPF feature, being able to do additional path checks, looking at how do I get back to the source. Took a look here at strict mode, verified on the reachable on the received interface. We do also have loose mode. Fairly straightforward for configuration. Just a one line on the interface to enable it. You do have a few other miscellaneous keywords or features that can be added on as well. So in this section we looked at TCPintercept and uRPF on the command line, as well as basic debugs and verification.